Some of the stuff that I'm going to give 2 brief lectures now, and some of this is repetitive, okay? Some of it you might have already heard twice, so I'm not going to dwell on that too much. Having said that, I think sometimes repetition is good for reinforcement, all right? So don't get too worried if you've heard some of this stuff before. So what I'm firstly going to talk about is race nomenclature. We've already talked about race identification and the different systems we have. I'll give you a bit of insight into the system we use in Australia, for example. Nice quote to start off with by Johnson and Newton from Canada. So this is not Roy Johnson. This is one of the Rust folks from Canada, or 2 of the Rust folks from Canada. I'm trying to think of Johnson's first name. It was Margaret Newton and Dr. Johnson, let's call him. But I think it's a nice quote because it basically is saying the importance of surveillance. So the price of security from rust damage is a continuous vigilance in the form of surveys to detect any pathogen changes and unrelenting efforts to develop cereal varieties resistant to any virulent races that may arise. So it's an ongoing process. We need to monitor the rust pathogens, and then the information we get from doing that surveillance has to inform the resistance breeding and also the post-release management of varieties. So it's more, it goes beyond just helping breeders develop new varieties and releasing them. The surveillance information that we get is very important for the post-release management of varieties. So, you know, a statement from, 60, 70 years ago, and it's still very relevant today. So I'm going to go, as I said, a little bit about repetition, but pathotype identification, the North American system, the Australian system, and then possibly Dr. Bhardwaj or Prasha, you might even, if we have time, mention the Indian system. I know Dr. Bhardwaj a couple of days ago was giving the designations, but no underlying explanation of the system that's used. So let's see how we go with that. This is a point I made the other day. The early system, I think I made this point yesterday, the early systems that we had, so this is going back to the work that Dr. Stakeman did at Minnesota on identifying pathotypes, were based on virulence or avirulence on differential genotypes. You heard the word differentials yesterday. Do you all know what that means? What a differential is? It's jargon, right? What it means it's a genotype, let's say a wheat genotype, that can differentiate. That's why we call them differentials. Can differentiate between 2 rust isolates. So you might have one wheat genotype, you put one rust isolate on it and it's susceptible, you get a second rust isolate and it's resistant. So it's distinguishing or differentiating between the 2 rust isolates. So it then is a differential. And it's a series of those differentials that we use to identify pathotypes. In the early days, that differentiation was based on the response of the variety, the genotype. They did not know what resistance gene or genes were present in the differentials. And that's what I've said there in the second point. And the interesting thing is that many, and even today we find this, many of the differentials we use, many of those genotypes we use to identify pathotypes carry more than one resistance gene, and that can be confusing. What we do now, though, importantly, is we report virulence and avirulence with respect to specific resistance genes. So we've mapped these genes in wheat. We know we've got LR1, LR2A, LR3A, all the way up to LR74 now. So we don't say an isolate is virulent on a differential, we say it's virulent on a resistance gene. It's virulent for LR1, it's virulent for LR3A. And you would know, I think, from reading the literature, there are a number of different nomenclature systems. I'm going to explain some other ones here to you now. But if we're publishing information on race identification, we should always put in a virulence-avirulence formula. All right, that then becomes like a Rosetta Stone. That allows us to translate between the different languages, between the different nomenclature systems. So in my papers, I would give a designation for a stem rust pathotype based on the Australian system. That in itself is limited in information. What I need to also put in is a virulence and avirulence formula for that pathotype. So that's all the genes on which, all the resistance genes on which that isolate, that pathotype is virulent, and all the genes on which that pathotype is avirulent. So just to illustrate that, and this is taken a table that I used the other day when I was showing you a bit about the gene for gene hypothesis. So here we have 3 differential lines, all right, with one pathogen isolate or a pathotype. And we would say, in this case, we've indicated that this one is low on the first differential, low on the second differential, low on the third differential. So our conclusion is that it's avirulent on all 3 differentials. We're not talking specific resistance genes here, we're just saying that it is avirulent on the differentials. The next one, obviously, is virulent on differential 1, avirulent on differentials 2 and 3. The next one, avirulent on differentials 1 and 3, virulent on differential number 2. And the last one we would say is virulent on all 3. Now, this basically is what Steakman did when he originally characterised races of stem rust. And this is taken from Dr. Steakman's paper that he published, where he has a physiological race designation, and it's just based on whether or not an isolate, so these are the isolates running across this way here, okay? So this particular physiological race number 1 was virulent on Little Club, virulent on Marquis, avirulent on Reliance, and so on. And you can see there's no indication there of what rust resistance genes those differential genotypes carry. It's just whether or not an isolate can attack the genotype or it can't, whether it's virulent for the genotype or avirulent. And that's how these original physiological race designations were given, just based on the ability or inability of each isolate to overcome the resistance in those differential genotypes, which could have been a single gene, it could have been 2 genes, it could have been 3 genes, they didn't know.